Hi class, this is Sir Alex. Again, welcome back to General Chemistry 2. We're going to continue on with the discussion of Lesson 7. And today we'll be discussing 7.2, which is about rate law. So let's begin by first looking at the goals of today's lesson. So at the end of the lesson today, what I want everyone to be able to do is to identify the rate law of a reaction. Later, we will discuss how to do that as well as first understanding ano ba yung rate law. Second is to be able to differentiate zero, first, and second order reactions. So after identifying the rate law, be also able to identify if the reaction is in the zero, first, or in the second order. So in order for us to understand what is rate law, let's begin by looking back at 7.1, wherein we discussed the rate of reaction. If you guys remember the rate of reaction, it's basically the change in the molar concentration, which is the delta bracket the reactants or the products. So it's either the A, B, if you guys remember that, delta, and then you have a bracket. The bracket denotes the molar concentration of a certain reactant or product. And in rate of reaction, we can use either the reactant or the product. And then divide it by over a period of time, which is the delta T. So if you guys remember this equation right here, if we have this reaction, a plus B is equals to C plus D, wherein A and B are your reactants and C and D are your products, then the rate law is this equation, wherein rate is equals to 1 over the coefficient of your first reactant multiplied by the change in the molar concentration of your first reactant divided by delta T. And these are all equals across the various elements or concentrations over time of different elements, atoms, or molecules that you use as your products and then reactants. And remember that in rate we have the negative of reactants because as the uh, chemical reaction progresses, our reactants are being used up, and as they are being used up, they decreased in the molar concentration. That's why we have negative, but for the products we use the positive because as the reactants decreases, the products increases. So I hope you guys remember this and remember how to solve for the rate law or how to solve for the rate of the reaction. Now let's talk about rate law. Rate law is basically the it's a mathematical expression. That's what I want you guys to not get confused. When we are solving for rate law, we are basically we're trying to find the mathematical expression. We are looking for a mathematical expression that could make us be able to relate the rate that we were able to solve using the rate of reaction and the concentration of the reactants. So for rate of reaction, we have to find the concentration, the molar concentration of reactant, but we have to divide it a certain amount of time. But for rate law, what we are trying to do is we're only looking at the concentration of reactants. We're not even looking at products anymore. We're only considering the reactants and its relationship to the rate of the reaction. So if we go back here, we have A plus B as your reactant and C plus D as your product. In this case, when we write the rate law, we do not even have to look for C and D. We're only focusing, since this is the product, we're only focusing on the reactants. We're not even looking at the coefficients here. We are only looking for the A and B. And the rate law or the mathematical expression that we are going to use is this. We have rate is equals to a certain constant called the rate constant K multiplied by the molar concentration of A raised to some m multiplied by the molar concentration of B raised to some n. Later, we will discuss what K, M, and N are. But basically, A and B here are the molar concentration. Again, these are not even a change in the molar concentration. This is just the molar concentration. This is just one molar concentration at a single time. So that is rate law. It's just a mathematical expression. So when a problem you would encounter tells you what is the rate law of a reaction, what it's asking you is it's asking you to create a mathematical expression. When it's asking for the rate of reaction, it's looking for a certain rate. It's looking for a certain molar per second, parang sa physics, meters per second. That's a rate, that's a velocity. In rate of reaction, we're looking for a molar per second. But for rate law, we are writing a mathematical expression. So basically, the rate of a reaction is basically equal to the rate law. Okay, so instead of doing all of this, uh, measuring a change of the reaction over time, we can just look at a certain reaction and at a certain K, or we can just use a certain molar concentration of the reactants and then a certain K and still be able to measure the rate. So again, when we are asked to do the rate law, what they're asking us is basically to write a mathematical expression. So this is the rate law. This is the mathematical expression that they want you to write for certain reactions. So let's identify what these include. And A and B, or the brackets A and brackets B, represents the molar concentrations of your reactants. Again, we are only dealing with reactants, not products. K is what we call the rate constant, which is a specific number for a particular reaction at a particular temperature. So different reactions have different K, and the same reaction at different temperatures also has different K. So K is affected by a particular reaction at a particular temperature. Again, so if you have two reactions that are very different, they would have two different Ks. If you have two reactions that are similar, but you conducted them at different temperatures, your K would still be different. So that is rate constant. M and N are what we call the reaction order. So reaction order is basically how much you raise the value of N of your molar concentration, and then by multiplying it by a certain constant K, you'll be able to find the rate. We're just gonna leave that for now. What M and N is basically reaction order. In 7.3, we will be discussing more what is reaction order. But for now, this is basically a integer that you use to raise the value of the concentration of your reactant. So for example, you have 1 raised to a certain value. So if you have a molar concentration of 6 and then raised a certain value, multiplied by K, you can get the rate of the reaction. One important thing about rate law is we can only get the rate law experimentally. So we have to conduct a experiment. We cannot get K, M, and N, or we cannot create the rate law without the use of experimentation. And the most common experimentation that we use is what we call the initial rates method. What does that do is, for example, we have this equation right here, is we keep for we do various trials. You can do as easy as 3 trials to as more complex as 10 trials. But what the initial rates method do is basically you just change the value, you change the concentrations of your reactant. So for example, you have this equation right here. And what you're going to do is you're going to keep constant one of your reactants. So meaning, for example, in this case, B, I don't want to change the concentration of B. And then what I'm going to do for trial 1, trial 2, trial 3 is keep changing the value of A. So maybe I have A, and then I have double the concentration, and then I can triple the concentration without changing B. And then we can solve for the rate at T1, T2, trial 1, and trial 3. And then after that, we're going to do is keep a constant and keep changing the concentration of B. So for trial 4 and trial 5, we have a certain, um, we can keep, for example, 2C, 3C, we multiply the concentration of C by 2, we tripled the concentration of C, but we kept a constant. And then we're going to solve for the trials 4 and trials 5. So that's basically what initial rates method is. You are changing, you are measuring how much the rate changes by changing the concentrations of one of the reactants. Okay, so by doing that, um, or we have to do that in order for us to identify the rate law. Lucky for you guys, we don't have to physically do the experimentation because they already given us the data of the experimentation. What we just have to do is identify the rate law using the information or using the data that have come from the experiment. So before we go on to that, let's um, take a minute first on understanding now how to identify the reaction order. So in reaction order, there are two things that you have to remember. One is for the reactant. There's the reaction order for the reactant, and there's also an overall reaction order. So let's take this for example where you only have one reactant, and this reactant is raised to 1. Remember, any number that is raised to 1 is basically equals to that same number. So rate is equals to some constant K multiplied by H2O2 raised to 1. This type of situation, we would say that we have a first order in H2O2. 1 basically means first order. As for the overall order, what we mean by this is basically M plus N. In this situation, we only have M, wala tayong N. So M, which is equals to 1, N, which is equals to 0, 1 plus 0, it's still 1. Therefore, we still have a first order, but this time we have it in overall reaction. So again, we have first order in H2O2 because H2O2 is raised to 1, and then we have a first order in the overall reaction, which is for overall again is M plus N. Now let's look at this example. We have rate is equals to some constant K multiplied by C4H6 raised to 2. So for 2, we call this the second order. So what do mean? So what that means now is that we have a second order for C4H6 because C4H6 is raised to 2. So we have a reaction that is second order in C4H6, and we have a second order for the overall reaction because again M plus N. We have 0, we have 2. Therefore, in the end, 2 plus 0 is still 2. We still have second order in the overall reaction. So what if we have this reaction? We have two reactants now. So the rate for this is some constant K multiplied by H plus raised to 1, or H minus raised to 1. So what we have now is we have a first order for H plus for H plus, and we also have first order for H minus. The reason we have first order is because they're both raised to 1. But for the overall order, we have m is equals to 1, n is equals to 1, 1 plus 1 is equals to 2. So this is the overall reaction. We have a second order in the overall reaction. So that's how you identify the reaction order, whether it's first or second for the reactants and the overall. So for now, you might not understand what is the importance of reaction order. But in 7.3, I will explain more what does the reaction order actually mean. Okay, but for now, this is how you identify the reaction order. So if I ask what is the reaction order of the reaction, what is the overall reaction order of the reaction, then you have to add all the power. Okay, the exponents. You have to add all the exponents. Okay, so like I've mentioned earlier, when a problem asked us to create a rate law, what they're trying to tell us is to create a mathematical expression. Write that. We want to create a mathematical expression. And the mathematical expression look something like this. Rate is equals to k multiplied by m, a raised by m, and b raised to n. And we can only be able to do this if the experimented were already done, like this example that we have here. Ozone in the upper atmosphere is being depleted when it reacts with nitrogen oxides. The rate of the reaction of nitrogen oxides with the ozone are important factors in deciding how significant these reactions are in the formation of ozone hole. So that's how you actually create ozone hole layers. One way is to react the ozone to nitric oxide. The reaction of NO and O3, NO being nitric oxide and O3 being the ozone, creates a ozone hole. And identifying the rate of the reaction helps us identify how fast the ozone hole is being created in this situation in Antarctica. So they have already done the laboratory experiment at 25 degrees Celsius, and these are the trials run. So for trial 1, you have a certain molar concentration of your reactants, and then they measure the rate of the reaction. The rate that they used is the rate of appearance of NO2. So after doing all these trial runs, what we're going to do now is use this trial run as our given to identify the rate law and the rate constant. Again, so what do we want by rate law? We want to create a mathematical expression that creates the relationship between the rate and the concentrations of the reactants. And then we also want to identify the rate constant. So let's move on. So adding a whiteboard to solve for this problem. Okay. Okay, so again, this is already our given. Parang hindi na natin siya isulat. And this is already the asked. So it's asking for the rate law and the rate constant. And the rate constant is K. Okay, so ano ba yung formula natin? So the formula is basically the rate law, which is rate is equals to some constant K multiplied by A raised to M multiplied by B raised to some N. Okay, so how are we going to solve this? Solution. In solving for rate law, there's two things that I want you guys to remember. There are a lot of ways to solve this, but the most common two ways is called an implied and explicit. So when we use implied, we're basically just looking at the data and be able to identify the rate law. But for explicit, we have to use algebra to solve for the rate law. In this problem, what we're going to use is implied. Implied is usually used when the numbers are obvious. Okay? Pero kung di sila obvious, use explicit algebra. I think the safest way is explicit algebra because then you will always get the correct answer. For implied, it requires some mental understanding on the math. That does not require for you to solve. It sounds easy in theory kasi hindi mo na kailangan mag-solve. Pero kung hindi mo naintindihan kung anong ginagawa mo, malilito ka. So in this case, I'll show you how to do the implied. Later, the next example, I will show you how to do the explicit, which is much safer, although mas matrabaho. So let's begin by solution. So what we're going to do first is to write your reaction. Okay, so our reaction is basically rate is equals to, ang mga reactants natin is NO, which is nitric oxide. So we have NO, raised some value M, and we have O3 raised to some value N. Okay, so this is what your rate law should look like. Pero hindi pa tayo tapos kasi kailangan natin i-solve yung M, kailangan natin solve yung N, and kailangan natin solve yung K. So what we're going to do is we begin by step 1. We have to solve for M. When you are dealing with M, you are dealing with a certain reaction. So a certain reactant, not reaction, a certain reactant. So some reactant raised to M. So kapag sinusolve mo yung M, ang hahanapin mo is varying or changing NO and constant O3. So after mong gawin yan, ang gagawin mo is look at your given. Look at the table that is given. And since yung K, remember, let's write our M and NO3N. Since ang O3 mo is constant and ang K mo is constant, ang nagbabago lang is NO, tama? Because this is varying. So ang mga nagbabago lang dito is yung rate and yung NO mo. What that means is you can actually remove na yung K and yung NO3, which will give you the relationship between the rate and your NO. So by looking here, yung trials na nagbabago yung NO is trials 3, 4, and 5. As you can see, nagbabago yung NO pero constant yung O3. So sa trial 3, ang reaction mo is 1.98 times 10 raised to negative 4 equals to yung NO mo, NO raised to M, yung molar concentration niya is 1.00 times 10 raised to negative 6 molar. And then for trial 4, mapapansin mo, yung rate mo is 3.96 times 10 raised to negative 4 is equals to yung molar concentration ng NO mo is 2.00 times 10 raised to negative 6 As for trial 5, mapapansin mo yung number ng rate mo is 5.94 times 10 raised to negative 4 is equals to 3 times 0 times 10 raised to negative 6. So, ayan, ang gagawin mo is implied. You have to look kung ano yung nangyayari between the rate and the molar concentration. One of the obvious thing that you will immediately see is if I increase the concentration of my NO, the rate also increases. So therefore, yung unang relationship niya is if my NO increases, if the molar concentration of my nitric oxide increases, the rate of the reaction also increases. So next, itatanong natin, so how much does it increase? So let's look at trials 3 and 4. So from trials 3 and 4, ang nangyari, I doubled my concentration. Tama? Let's remove this. I doubled my concentration. So 1 times 0 times 10 raised to negative 6 times 2 is this. So I doubled my concentration of NO. Pero kung mapapansin mo, ang nangyari sa okay, let's try that. Ang nangyari din sa rate of reaction mo is it actually also doubled. So 1.98 times 10 raised to negative 4 is 3.96 times 10 raised to negative 4. So as I double the concentration of my NO, the rate also doubles. So let's look at this. So from trial 1 to trial 3, 1 to 3, so I tripled my concentration. But if you look at trial 1 to trial 5, sorry, trial 3 to trial 5, as you can see, nag-triple din yung rate. So, kumbaga, meron siyang 1:1 ratio. So, this type of relationship ngayon, kung mapapansin mo, is it's a very direct proportional relationship. Let's move up. It's a direct proportion relationship. Rate is equals to NO. So if I double my NO, my rate also doubles. If I triple my NO, my rate also triple. So mangyayari in the end, ang relationship niya is basically rate is equals to NO. So, ibig sabihin ng NO mo is actually raised to 1. So, this is first order in NO2. And M is equals to 1. So, bakit natanong nyo, sir, bakit 1? Kasi anything raised to 1 is that same number, di ba? So, NO raised to 1 is equals to NO, which leads us back to this. NO raised to 1 is equals to NO, so rate is equals to NO. Therefore, if I double the NO, my rate also doubles. If I multiply this by 3, my rate also multiplies or increases by 3. So NO is in the first order, therefore M is equals to 1. Okay, so that is your step 1. Step 2, identify N. Okay, so how are we going to identify N? Similar thing, as for N, ang focus ng N is O3. So what we're looking for is varying O3. And this time you want constant NO. And similarly, if we have this rate, K is equals to NO M O3 N. Since NO is constant, AK is constant, you can just remove this too and create a relationship between the rate and NO3 N. So now let's look at the trials wherein the O3 is varying. And kung papansin nyo, ang nag-vary na O3 is trials 1, 2, and 3. Tama? Okay, so for trial 1, makikita natin that the rate is 6.60 times 10 raised to negative 5 is equals to the molar concentration of 3 times 10 raised to negative 6. Sa trial 2 naman, yung rate mo is 1.32 times 10 raised to negative 4 is equals to 6.00 times 10 raised to negative 6. And sa trial 3 mo, kung papansin mo, yung rate mo is 1.98 times 10 raised to negative 4 is equals to, the concentration is 9.00 times 10 raised to negative 6. And using implied, again, ang papansin mo, from trials 1 to 2, you doubled your molar concentration of ozone. Ang mangyayari din sa rate mo is it actually also doubles. So the same thing then. So if I look at trials 1 to trials 3, I triple the concentration of O3. 3 times 10 raised to negative 6 times 3 is 9 times 9.0 times 10 raised to negative 3. The same thing if I triple, or if I got this 6.60 times 10 raised to negative 5 and multiply it by 3, I would get this answer. So similar siya dun sa first. Rate is equals to O3. Okay? Tama? So if I multiply this by 2, ang nangyayari din dito, it increases by 2. If I multiply it by 3, it increases also by 3. Therefore, this is a first order reaction. Not reaction, first order in O3. Therefore, N is equals to 1 then. And that would lead us in the rate law. So how you identify rate law now? So you have a rate law of K multiplied by NO plus O3. So this is your rate law. So that's your answer. Okay? So now what you want to do is yung second question na. Ano ba yung K? So how are you going to do K? This is the step 3, identifying K. So as for step 3, use any of the trial. So use any of the trial and then just substitute the number from your rate law. So you have a rate is equals to K and O3. So K is actually equal to rate multiplied by NO O3. So substitute, let's say, trial 1. So we have to substitute trial 1. You can choose any trials you want, and I just use trial 1. You can use trial 2, trial 3, it's up to you. There is no, you can use any of the trials and you will get the correct answer for K. As for trial 1, we have a rate of 6.60 times 10 raised to negative 5 multiplied by, this is 1 times 10 raised to negative 6. And then we have 3 times 10 raised to negative 6. Multiplying that just using your calculator. you would get that your K is equal to K is equals to 2.20 times 10 raised to 7, and the units for your K is liters per mole, liters per mole per by multiplied by second. So basically, let me just rewrite this. Sorry. So this is your units for K. One thing though for units, units is dependent kung ano yung overall rate order mo. So this case unit actually changes to suit your needs. Later I will show you how you identify the units for your K. Pero for this purpose, for intents and purpose of this problem, K is actually equal to 2.20 times 10 raised to 7 liters per mole seconds. So that's how you identify your rate law, and that's how you identify your K. Okay, so this I'm gonna end this now because it's taking a little longer. I don't want to have any issues with the video, so I'm gonna see you guys on the part 2 of the video.